Hello students. Today our topic is related to modern periodic table. Okay, this topic is very relevant for standard 11 chemistry. Now see, what is modern periodic table or what is periodic table? Periodic table is the periodic arrangement of the chemical element into rows and column. Now see, this is the rows which is known as period and this is the column which is known as groups. Now see, our main topic is atomic radius. Okay, what is atomic radius? Atomic radius is the total distance from the nucleus of an atom to the outermost orbital of its electron. Now see, variation of atomic radii. How the variation occur? Now here we are taking the elements from left to right: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. What is happening from left to right? The number of proton increases, nuclear charge also increases, and force of attraction increases and atomic radius decreases. But down the group the number of cell increases, so down the group atomic radius increases. But this is the general case. Okay, from top to bottom atomic radius increases, left to right atomic radius decreases. But there is some exception. Now see, there are some exception in the case of chemistry. As we know that from left to right atomic radius decreases, but in the case of helium it has a larger atomic radii or larger size than hydrogen, so it does not follow in the case of helium, so it is one of the exception. Now second case, from lithium, beryllium, boron, carbon or nitrogen, oxygen, fluorine, neon, atomic radii decreases. Okay, now as we know that atomic radius from left to right decreases, but in the case of neon it increases. This happened due to the case of van der Waals radius. Okay, it is greater than covalent radius. Okay, now next case, in the case of D block. Now see, in the case of D block element, the variation in the atomic radius: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Now see what happens. In the case of scandium, titanium, vanadium, atomic radius decreases. In the case of chromium, manganese, iron, cobalt, atomic radius constant. In the case of nickel, copper and zinc, atomic radius increases. Here what happens? Less electron repulsion. Here electron repulsion increases, here electron repulsion more increases. So what happens? This is the trends it follows. Okay, scandium, titanium, zinc, vanadium, then chromium, manganese, iron, cobalt, copper,